Welcome everyone back to our final industry panel for the day. And I know that there's a student panel following this late in the evening where many of you are going to kind of sign in. So through the day, we've had heaps of students coming in and out and staying through right from 9 a.m. So I'm quite excited to see that. And I'm sure as the evening progresses, we're going to see more traffic coming through. So with that, let me start by welcoming our fantastic panel. And today we're going to talk about a future with data and AI and careers in computer science and mathematics. It feels rather redundant saying, I mean, what do we mean like the future with data and AI? We're already living a present with data and AI, but really we're going to talk a little bit more about how some of this is changing. I'm going to introduce my panel quickly, and we'll go around having some very interesting conversations as well. Welcome Aparna. Aparna is a researcher with the AI for Social Good team at Google. Aparna got her PhD in computer science from the ET at Zurich, and she pursued a postdoc at the Disney Research at Zurich and finished her bachelor's and master's from IIT Delhi. Yeah, there's two soft corners there, Aparna. One is we had a fantastic session by Dr. Manish Gupta at Krea, and still strongly recall, which I quoted in my last session, that when we actually asked him at the end of it, what kind of graduates are going to be important for the kind of work you did? And he said, no, we need philosophers and we need social scientists. So it was really exciting. And I think it left a lot of students going really, what did you just say? And ET at Zurich, I have very fond memories of working for them and on a project, and it's one of those most professional research-based universities I have done any work for. So thank you so much for joining us, Aparna, and thanks to Dr. Gupta for nominating you to be a part of this, and welcome. We're joined by Pradeep. Pradeep Gulipalli is the co-founder of Tiger Analytics, and he's worked with clients at Fortune 100 companies and startups across, to enable scientific decision-making in their organizations. Pradeep holds an MS from UT Austin, Texas Austin, and a BTech from IIT Madras. Tiger Analytics today, I mean, you talk about risk analytics, you talk about consumer analytics, you talk about analytics for decision-making. You can't quite ignore the kind of work that Tiger is doing. So many congrats, Pradeep, on creating, Tiger Analytics and for the work you do. And thank you so much. We understand how busy it is for you, but thank you for taking the time to be here to talk to some of our young students and their parents. Thank you so much. We're joined by Pallavi Mishra. Pallavi is the principal at Oak Ridge International School in Bangalore. Pallavi has close to 2 decades of experience entirely in international curricula, I mean, including IBDP, IB, MYP, PYP, IGCSE, AS, and A levels. And she is an IB evaluation leader, and she successfully spearheaded the authorization process of all the 3 IB processes. So if anybody is even fairly familiar with what the IB process is and an evaluation is, you will know the level of details one needs to get into this. So Pallavi, congratulations for keeping that smile on, but it's an amazing process, and I think you would have learned so much from that. She's also a UGC National Education Test qualified teacher and a CIDIT teacher, and mentored by the UK at Keele University. So thank you so much, Pallavi, for joining us. From our own Krea family, we're joined by Dr. Gaurav Raina. Gaurav is the chair of the Research Council and the visiting professor of mathematics and computer science at Krea. He holds a PhD in mathematics. He's a Srinivas Ramanujan scholar from the Trinity College at the University of Cambridge. He's also part of the faculty in electrical engineering at IIT Madras and a visiting research fellow in mathematics at the University of Cambridge. So somehow there is going to be this IIT fraternity that's going on in the panel, but thank you so much, Gaurav. There's so many hats at Krea that you wear, and I'm always amazed that you managed to give us your time and always kind with, you're very generous with your time and the responses on such occasions. So thank you so much for joining us. Joined by Dr. Prathamesh Prathamesh is the Assistant Professor of Computer Science at Krea, and he works at the intersection of logic, computer science, and mathematics. He did his undergraduate studies in mathematics at St. Xavier's and an integrated PhD in mathematics from IISc in Bangalore. Thank you, Prathamesh. Thanks for joining. My fond memories with Prathamesh is always sitting on those fantastic scholarship evaluation panels on global scholarships, and Prathamesh always comes up with this most interesting questions around logic and data to kind of push our students to think very differently. And what I really love about sitting with Prathamesh is how he allows for the student to deduce the answer themselves if they made an incorrect one. So I'm really excited with this panel and the variety that it actually brings to us. So thank you, everyone. Without further ado, let's get going a little bit in terms of the whole topic for today, which is about data and AI, and I'm sure there's a lot of interest out there. So I'm going to start this a bit with Pradeep, and I'm going to start this with you. So really, you know, this whole advancement in data and AI is kind of, it's there, it's glaring, it's what has happened in the last few years. It's not something, the impact of something we cannot, you know, ignore. But even as you were driving that, you know, even if you're riding in that driverless car and you were looking at the rear view mirror and say, you know, look at what has happened in the past decade around advancements around the analytics and the AI area. What have you seen as some of the top observations that's happened? And really, is there anything that caught you by very big surprise in terms of what's really happened in the past decade?
Hi, everyone. I'm glad to see, first of all, glad to see all the interest from the students on this topic. A very relevant one for everyone to be interested in. I'll start off just with some caveats saying, hey, you know, we have professors here who might be who might say, hey, this is AI, this is not AI. I'll take a slightly broader approach, right? I would say what we are talking about today in terms of the impact we are seeing, what we are broadly, the society, what it's labeling AI, it's a broad umbrella of things, right? So what can technically be defined as AI? What could be, you know, mathematical models? What could be quantitative techniques, which need not necessarily be in the true sense AI? We call all of that AI today, right? So think of it as, you know, quant technology, and machine learning, all of these coming together to solve problems, right? So this is in my conversation today, we'll use the word AI a bit loosely this way, right? So that and as you think about your careers, probably that's how a lot of you would think, whether or not it's in sync with the true definition, the academic definition of AI. Anyways, with that in mind, I would say that this is definitely not new, right? The whole data and AI wave we are seeing, not new by any stretch of imagination. Now, if those of you who've been if you've been paying close attention to how people figured out, I know how the rotations of the Earth, revolutions around the sun, or positions of the stars. There's a lot of data analysis that's been happening ever since, right, for centuries together, and it has gradually evolved to the degree in a lot of last century. It was organizations have been using a lot of these algorithms, which have suddenly gained cult status now. Variants of that for a while now, right? So all of this has been happening for a while. Just that we are now beginning to see a lot of these formalized as a problem-solving tool in a variety of domains. Like earlier, it used to be in pockets here and there, but now variety of domains across the society, across organizations, we are seeing this, right? So the last 10, 15 years, some dramatic changes that have happened was, I did not imagine that storage and compute power would become so cheap, right? So, we were all, at one point, the kind of compute that was needed, computational power, the memory to store all the data and all of this, it seemed like, hey, that's only the realm of large organizations, people with deep pockets, all of that. But now, hey, anyone, you and me, you want to fire up the kind of compute power that probably NASA never had when they launched their first space shuttles, etc. We have more than that. We can fire up more than that in just like a instant, right? So this has been one of the dramatic changes which has helped a lot of this this push to adoption of AI. Not just that, right? So this gave us power to analyze huge amounts of data, right? So when I spoke about in the past, things were around analyzing a certain scale of data, but now you're talking about internet scale data, petabytes of data, very comfortably you're able to analyze it. So think of it, if you are used to analyzing data in an Excel sheet, this is astronomical scale of that. But now we are able to analyze that, and each one of us with just a computer have the power at our hands to analyze this. The algorithms which made it possible, the technologies that made it possible are being put in our hands, right? Open source has really taken care of, and just the pace with which things got open sourced, with which they got put in your and my hands, that was again very, very welcome over the last decade, right? What just advancements in these fields meant that when we spoke about AI and analytics, what was usually associated with numbers, that changed. Now suddenly it was just not about numbers. We're saying that, hey, we could analyze speech, we could analyze text, we could analyze audio, video, things which were in niche places in some research labs. Now they got mainstream, right? And there are all these once it became feasible to do all of this, then people started to look at, hey, what, there have been all these problems I've been sitting on, and suddenly I have tools that I could solve, right? So these were, I'd say, hey, some big shifts that I've seen over the last 10, 15 years that really changed how people were looking at what kind of problems we could solve and what AI and analytics can do for me.
Interesting. Yeah. I'm going to move to Gaurav for the two hats. One is everybody knows him as an academic, but Gaurav has very strong industry links as well. So Gaurav, really, what's the academic understanding and not so much the academic understanding on what's really happened in the past decade as far as the analytics and AI goes, according to you?
So let me sort of summarize it. I think a very good introduction to AI has already been given. So if I look back in the review mirror, then I think there's been great adoption by AI by internet companies. There's an increasing adoption of AI by enterprises. And now we're going to enter an era of consumer AI. So financial services for me, healthcare for me, for the individual. Right? Mm-hmm. So this has all been happening. The second thing is, so that's one. Second thing I really want to say is I think people vastly overestimate what AI can do in the short run, and they're massively underestimating what it can do in the long run. So you have these sort of media stories which says that AI is going to take over, and there's a tendency to think that it's going to have dramatic changes in the short run, but people are vastly underestimating what it's going to do in the long run. Now, as far as industry academia connect is concerned, I mean, as I see it now, a lot of industry problems are turning into very sophisticated research problems. So this distinction between academia and industry is really, in my view at least, diminishing. The problems that I'm seeing in industry right now are highly non-trivial problems, and it's not just a question of an application of known algorithms, but they're getting to a level where I think it's getting fairly sophisticated from a research standpoint as well. So the sort of porous boundaries between academia and industry is blurring faster, I think, than what a lot of people sort of recognize at this point of time. And I probably want to sort of just end with one point, which I think would be slightly controversial, but it's worthwhile for people to think about. And that is, this is the time I do think that is the time to reflect on what could possibly be the human use of human beings when machines almost run everything. not everything, but almost run everything. And that really, I think, especially for the next generation, is really point of thought and reflection, that this will certainly happen within our lifetimes, and probably slightly faster than we might give it credit for.
Yeah, thanks, Gaurav. Very, very interesting opening remarks from Pradeep and you. I want to move to Aparna on this and get your thoughts, Aparna, in terms of just working in this space and something so specific as well within the social good. But besides that, just your lens about what's been the big shifts in the past decade.
Hi, yeah, I think already Pradeep and Gaurav have given a fantastic overview, but just to add on to it a little bit, I completely agree. Like, while there have been, great progress in like fundamental research in AI, again, AI is a very holistic, it's a very, broad term. I can specifically comment on machine learning, which I'm a bit more familiar with. AI could be robotics, it could be computer vision, it's everywhere. There have been such, a tremendous progress there, with deep learning, with deep neural networks, convolutional neural networks, and so on. And all of this existed even before, but, just like Pradeep mentioned, with now large amounts of data being available, as well as the compute power, GPUs, TPUs, and so on, without which you couldn't solve such complex problems, without which you could not process such huge amounts of data, without which you could not, train more such deep neural networks, which earlier could only be run on toy data sets, but now it's become possible to run it on, millions of images very easily. And thanks to all that, it has become so easily accessible. It's everywhere, right? Whether we're watching Netflix or searching on the web or ordering groceries, it's everywhere. So it's fantastic that all of these things combine together, right? The progress in research, the progress in data and compute has contributed to it. And there is still so much more to be solved. Like Gaurav said, we're just looking short term. There is so much more to be solved. I can give examples from my perspective. Like I was earlier working again with an ML team called the Earth Observation Science Team, where we were using satellite imagery to solve, to use ML for climate-related problems, for environmental problems, and now in the AI for social good team. And I see other works happening, at Google, other companies, for instance, with natural language processing. There's so much to be done there. I mean, I see people using voice search in like Kannada or, in languages which you would think are like low resource languages. But so there's still a lot more to be done, because traditionally most algorithms were developed, with the broader population in mind, with the, let's say, assuming that majority of the population speaks English or Hindi in India, which is obviously not the case. So, reaching out to the next billion users, as we say, that there is still a lot more to be done. While also making it accessible to everyone, not just solving those problems, but actually making sure those problems get deployed. So, yeah.
Fair enough. Yeah, I think, yeah, that the whole nuance that you're talking about would be interesting as we talk about the future in the next frontier. Pallavi, if I could just get your thoughts around this a little bit more in terms of where are you, I mean, irrespective of whether you're working in it or not, but what are some of the big things that you've heard which has really surprised you as far as the area of analytics or the data or AI goes?
Thank you, Kala. First of all, thanks to all the panelists. Very enlightening views and very technical and really impressive. Thanks, for making me part of such a exciting panel here. First thing I want to say is that AI has, contrary to what I think Gaurav was saying, as an educationist, I feel AI is an enabler, it's an enhancer, it's a tool which will simplify life, reduce work, negate doubling of work, not just in all industries, whether it's healthcare, whether it is policing, even in teaching and learning. I think it's a big game changer. And I feel that it has evolved in the main understanding that the main paradigm shift is that instead of it being something which will threaten humanity or humankind or take away jobs, it'll actually create more jobs. I feel it may take away the redundant bits, which, like I was saying, it will simplify, but it will actually be a big assistance. It'll not be something which will impede our growth or impede our well-being. It will actually assist in it. Another thing that I want to say is that, especially at this time in COVID times, I think AI has been a big, huge help, because like so many of the panelists were mentioning, those predictive index, which help determine trends, patterns, and also preempt situations. And I think all of us are right now depending on it hugely for our own safety and health. So I believe AI is welcome. It has been around, but it has been underused. And the fact that a person like me, who has a master's in English, has developed interest in AI itself shows how big it is and how impactful it is. I wouldn't have dared to speak to people who are mathematician earlier, but now I can. Yeah, thank you.
Fair enough. And I guess that's really important to also, not one is, working in the field, but it's about, do you feel the impact and where do you feel the impact? And that's really the view that we want to bring. And Prathamesh, I really want to end this round with you to just ask a bit about, this whole idea of numbers and analytics, and, what's been some of the big impact areas of this that you've seen in the past decade?
Thanks so much. So again, just to kind of just come back to the list framework itself of AI, right? I mean, so I think I tend to agree again with the points that were made earlier by Gaurav, Aparna, and Pradeep, that essentially AI is, first and foremost, as I said, just wanted to just make clear that it was a very broad field, right? And when we talk about artificial intelligence, just to have the conceptual clarity, we're trying to simulate human processes, mental processes. We are trying to kind of mechanize these processes, right? So that's essentially how we have to kind of take this kind of slightly broad view. For instance, there is something called as knowledge-based agent modeling, right? And where we try to understand, which is not necessarily to do with just numbers or analytics, but you also want to understand how we actually reason when there is insufficient information, right? What is the sound way to kind of go ahead and reason? And that's also an aspect of how do you want to reason about it, or what kind of reductions you would make, what kind of inductive assumptions you're going to make. So these are very important aspects of AI. And it's also important, as we say, when we go on to taking about AI itself, there's this broad view of AI. And so some of the interesting phenomena itself, of course, within the field of machine learning and computer vision, we've seen a fair number of developments, which were again pointed out earlier by Pradeep, Aparna, and Gaurav, about because the use of the growth of computing technologies, for instance, like cloud computing, as well as the GPU processor speeds. At the same time, we are also seeing some very interesting challenges in terms of the other forms of AI, which are basically what you would call the logic-based forms of AI, where we are able to kind of build systems that can basically able to deduce, let's say, whether statement A follows from statement B, right? I mean, is there a logical sense of links that kind of can actually tie them together? So there have been some interesting results that have actually come out, and one of the interesting results that came out of Texas Austin in 2014 basically went on to solve an old problem about Pythagorean triplet. So that, I think, is one of the major interesting results, and it had booleans and booleans of terabytes of proof, what you would call a mathematical proof, because essentially these are reductive systems. So that's, I think, one interesting kind of a development that we have seen with the growth of computing technologies. And at the same time, with numbers, we do see a fair number of interesting, for instance, you have the AlphaGo, you have, as well as your everyday technologies, for instance, series, right? So, and as well as at the academic front, we also see very interesting results. For instance, today you can imagine astrophysics as a field, where you actually take these large complex data sets of images of the stars in the skies without actually performing some kind of analytical tools on them, without performing some kind of a computational tools on them to be able to deduce, like, okay, the object am I seeing? What kind of an object is it? What kind of information can I actually derive from this image of the space that I actually derived from some satellite far away? So that, I think, is one of the most interesting developments we've actually seen in the last decade or so. Yeah.
Thanks, Prathamesh. Thank you so much. And I know, yeah, it's been interesting in terms of the observations in the past decade. And I really want to talk to a little more deeply with Pradeep, Aparna, and Gaurav in terms of really the industry play to this. So clearly, whether that's industry solutions and is broadly depending a lot more on data, on the analytics it provides, and this whole the fact that data is the fuel and AI being the Ferrari that actually looks so great. But I just want to understand as well, Aparna, if we could start with you to just what are some of the big surprises that's coming our way with thinking about how this whole space of artificial intelligence in whatever form that you wanted to talk about, or this whole space of analytics? What are some of the big surprises coming our way in terms of, we're talking about, let's say, next 10 years?
So this is obviously my opinion, so maybe
Yes.
people agree or not agree. So as I said, working with machine learning, I feel two really big aspects we need to really strongly work on are fairness and explainability. So, people think of machine learning as, magic, that it's a black box and you throw data into it and just magically results come out. You can, predict how a sentence is. You start, type 3 words and it can predict what the next word is going to be. It can complete your sentences. It can understand your speech. It can look at an image and tell whether this image is of a car or a cat or what. But a lot of this a lot of these models are built by being trained on large amounts of data. So it's really our responsibility as developers, as research scientists, to really understand what this data represents, where this data comes from, how it is distributed. Because if you throw, as is already known, if you throw a face recognition algorithm and data into a face recognition algorithm and provided data from, say where 70% of the data is coming from the Western world, and you show it a new image, there's a high chance the model might think, well, this person is from the West, which may not be true. And, depending on the domain, making an error can be very sensitive. If it's a Netflix recommendation, I can live with a bad movie recommendation. I would have wasted 1 hour of my life on a bad movie. But if it's a medical diagnosis and you've done, you've used image recognition to diagnose, have an early diagnosis of whether this person has diabetes or not, or a more serious problem, there making an error can have a much higher cost. So there's both parts to it. You really need to understand your data because that heavily influences your model, and also understand your model, make it explainable. Right now it is very difficult. It's a very challenging problem, and there are people working on this problem. But the more complex these models have become, the more complex these neural networks have become, with hundreds of layers of neurons, abstracting, extracting more and more abstract features. Even as we, the ones working on these models, don't understand sometimes when the results come out. Is it because our model is not working well, or is it because the data was not representative of what we thought it would be? So yeah, to me, both fairness in understanding your domain and what consequences it can have when you train a model, the explainability of it to understand.
Yeah. Thanks, Aparna. Thank you. I know, we just ran a poll in terms of the audience here, and I know we have a very sizable, nearly 80% students tuning in. And there's some important things that Aparna said there, students, and we're going to talk about that in the next round, where we're talking about, one is, as she said about, there is a lot of this AI and data happening, but it's about understanding the context. And we'll kind of elaborate that a little bit more in our next round of discussions. Pradeep, if I could kind of ask you a bit around, if you were to talk to this bunch of 100-odd students tuned in and say, these are some of the big things that you can expect for AI or analytics to impact, how's that future looking?
Yeah, sure. So, so today, if you take a look at the world today, you would see that there are clearly these pockets where AI is playing a role, right? Whether it's your non-Netflix recommendations or, usually, the internet companies, the e-commerce, the E and I side of things, right? That's where a lot of impact is. And you see outside in the physical, the non-digital world of things, you see that, hey, it seems just more or less the world of the old has not been touched by AI much. So that's going to change dramatically, right? So there's a lot of the digital transformation, that's the buzzword these days in the industry. And that's going to happen, meaning you will start to see the implications of AI everywhere, not just the internet companies and that, but also broadly across the board, right? So we are talking about, hey, you'll see many more smart objects. You will see, whether these be like small devices or factories, buildings, cities. They will truly start to become smarter, right? In terms of us being able to sense data, being able to influence them, and so on. That's going. What this means is, you will be able to solve a whole host of new problems now that all of these are becoming smarter, right? Things which you would have said, hey, we'll need to live with this. Now suddenly you'll be able to make life better, because hey, now these are responsive, these are intelligent, right? So that opens up a lot of opportunities for all of you to think about, hey, what kind of problems that you could be able to solve. Along the way, something that Gaurav mentioned earlier, that's coming very thick and fast, does this personalization, right? Personalization today stops with what your Amazon or Netflix shows, but think of personalization in healthcare, right? So if there could be medicine which is personalized to your genetic makeup, right? Healthcare delivered in a specific manner. All of these could have very, very big implications. And the more digitization that happens generally outside, which means that any experience you might have, any experience it might be, I just spoke about, say, an entertainment or a healthcare, but take it, whether it's education, nutrition, whatever area, there is an opportunity for it to be personalized to you. Right? It could be related to your likes, dislikes, or it could be related to your genetic makeup. Worst case, maybe it is being governed by a big brother and personalized to you. Those are things we need to worry about. But these are the shifts, these are the opportunities that we will see, that all of us will be participating in, either as consumers, as creators, in the future. Few things that will happen definitely is a lot of the standard tasks across all these, whatever be the domain, they'll start to get automated. All of that is going to happen, right? We're already seeing that even experts in different areas, they are being outperformed by AI. So what will this mean? The role of experts would change, right? So generalists in an area like, hey, you and me, who might not know something about a particular domain, we will get very powerful digital assistants, right? Which will suddenly make us feel like experts in that. So the role of knowledge, role of experts, role of AI, there's going to be a flux, right? Some of these things will happen. Broadly, these are two aspects I wanted to say. Hey, what is definitely coming our way in terms of consumers, what we can expect, and then what we can expect in terms of opportunities that lie ahead of us, problems that we can solve.
Yeah. I really want to touch more on the big problems that we think, and I want to go around the panel. But before that, Gaurav, anything that you want to add beyond that in terms of the big things that's coming our way that the world of data and AI will touch on?
Yeah, sure. Just quick reactions. I think academically, I think the intersection of mathematics and computer science, along with domains like ethics, psychology, and neuroscience, is really fertile ground for new breakthroughs. From an industry standpoint, look out for all the industries that are already very well placed to generate a lot of data. And putting a context within India itself, there's been massive effort and massive progress being made in digital and mobile payments. So as that data keeps getting generated at the volume that we are seeing it today, that will most likely, within the Indian context itself, lead to personalized financial solutions, personalized financial services in the form of personalized loans, personalized insurance products, personalized investment strategies. So wherever you see lots of data coming, you're bound to have innovation and customization happening. So within the Indian context, I think financial services is really ripe for a lot of that innovation in India over the next 5 and 10 years.
Yeah. Interesting. So students, if you've heard that, that really is a summary in terms of, some of the, as Aparna started by talking about, all this is going to happen, but the important thing is using that, all that data and AI, and where is the context of it, and we're going to come around to a little bit of context. And Pradeep and Gaurav did talk about the level of personalization that's going to happen. So from broader solutions, at one point we're talking about looking at the space and analyzing to what's my personal finance, what's my personal healthcare. So that's really the realm of what it's going to touch. And Pallavi, I wanted your thoughts a bit about if you were to kind of, in your understanding of some of the big problems that, let's say, your students in your school studying computer science and mathematics who want to work in this space, what are some of the big complex problems that you think this advancement in machine learning, this advancement of the data is actually going to allow for us to solve, and some of these graduates to work in some of these big problems?
Yeah, and that's a very important question. So for example, ours is an IB Continuum school, and we are all about real life application of knowledge, research based on first identifying a real problem and solving that problem. And that's why children are taught design, coding from grade 5 and 6 onwards, and right up to, so computer science is no longer reserved for 11th and 12th, because it's clearly understood that is something that students need to interact with a little earlier. And so yes, in that sense, real life application, problem solving is definitely an approach that is now part of teaching and learning. And one thing is that there is a dearth of this talent, because like you had rightly pointed out, I think you said in the introduction, that many traditional styles of teaching do not include this approach. So it becomes very much for students who have come from, say, curricula which is more content driven. They will find it difficult to adapt. I'm sorry, am I frozen or you are? Okay. Yes.
We can hear you. Yes.
Yes, I think yeah, I'm done. Thank you,
Okay.
Aparna. Kala.
Yeah, thanks, Pallavi. Prathamesh, I wanted to kind of, this is interesting what Pallavi kind of mentioned now. It's about this whole coding and computer skills that started earlier on. And I want to talk about this, this next round in terms of the skills itself. So it's really, we're talking about, hey, these are the big things that's going to come in, and these are some of the big shifts that's going to happen. But if we are talking about AI being applied in some of the complex situations that we're going to talk about, really is it about just knowing the coding and mathematics? And hence, what else is this particular study going to need for it, so that young graduates of today are part of the solution for some of the big complex problems that data or AI can solve?
So that's a really interesting question, Kala, and thanks for asking this. And I think a part of the hint, as you kind of said, there is of course one way of looking at it where you just look at it as this one particular technical problem and you kind of reduce it to a slightly formal technical language and then try and just attempt it. But to understand whether this real life situation that you're actually capturing essentially captures the problem on hand with that technical means well enough, right? And that technical means sufficient to essentially be able to answer meaningfully, or what kind of techniques that we really need to apply to be actually able to solve it meaningfully, requires going beyond your immediate technical coding skills or your mathematical knowledge. I mean, which need not necessarily be technical by itself. So essentially, for instance, so philosophy plays a very important role. So I don't know, for instance, if anyone's really read this book called by Judea Pearl called On Causality. So he was one of the early pioneers in machine learning, one of the statisticians, applied mathematicians, computer scientists. So for instance, he has his entire thesis in his recent, it's a very popular science book, for instance, on what does it mean, for instance, when I say X causes Y, right? When I say something causes something. So essentially, in what often in artificial intelligence, you're trying to understand what causes what, and you're trying to identify sometimes causes, sometimes relationships between things that you see. So to understand that, you need to have a certain sort of philosophical perspective to understand the notions such as causality, notions such as relationships, right? Very complex forms of relationships that can exist between objects in the real world. And it also needs to, we will understand what exactly is a scientific endeavor and what is not, right? Quite often, for instance, I think as this was pointed out by Aparna before, that people can just very enthusiastically take on this machine learning as this black box and just apply it to something without realizing the consequences, right? Often. And to have a sense of where exactly is the kind of processes that they're making, is it actually a scientific process? Is there a scientific method behind what we are really doing? Enables us to understand what is philosophy of science, what is science, what qualifies as a scientific process, what is not a scientific process, right? And at the same time, for instance, in very complex situations that we're really applying the world to, for instance, let's say even something like COVID data. If I want to say I've just build a small model to build my using machine learning for securing data, I need to be able to understand sociology, because there are very complex ways in which human beings interact. What are the sociological clusters? What are the groups that exist? Or even, let's say, to understand relationship between, let's say, crime and neighborhoods. It's very easy to just plot a diagram and say, hey, look, I mean, I find a relationship between crime and neighborhoods, which I have my data that kind of reveals. But essentially, to understand what kind of consequences such a relationship could have, or what kind of processes essentially enable us to have a much deeper look at what exactly is the sociology, for instance, of crime, right? So questions like that, or sociology of race, I think is where we need to have a very broad perspective, which includes phenomena right from something like understanding your philosophy at various levels to sociology, or even sometimes history, possibly. Yeah.
Yeah, fair enough. I think, yeah, that's so well put in terms
Um,
of,
Kala, can I
yes.
come in? I'm so
Yes.
sorry. I realized I didn't answer your second part of your question,
Yes.
which was about how the graduates can help. And yes, I really want to use this opportunity because there is a real requirement, at least in the education industry, for AI support. And for example, in this time where we are trying to ensure uninterrupted learning or blended learning models that we are trying to develop, that can only happen through the support of AI. And for example, we are developing an education strategy where we use AI to detect patterns. What are the questions students ask? What are the curiosity levels in different types of students? How to do differentiated teaching and learning, which is a big problem because generally it's one size fits all, whereas differentiated teaching and learning can be enhanced through AI, and that's something that the graduates should think about. Another thing is how to create a more equitable society through AI. So, for example, finding solutions so that rural areas, schools which do not have access to all the infrastructure that other schools have, if they can be helped, and there can be some problem solving there. So just wanted to just remember that you had asked me that question.
No, application in education and where graduates should work is really important. Yeah, very well put, Palvi. And Pradeep, I wanted to direct this to you. So with, I mean, what are some of those big problems that, or challenges or opportunities in some sort of way that keep you awake at night and keep you excited in terms of, okay, these are some of the big things that need to solve. And what I want to ask you is also leading to that, is some of these contemporary complex issues, are they just going to be solved with students coming with mathematical and computing and coding skills? And do you see that, do you see a requirement beyond those technical skills to be more sensitized, to be part of this larger solution to solve some of the complex problems?
Yeah, and I think we all know the answer to that. We just cannot solve these problems just using a technology. It's like one hammer for everything. That's not going to work. So let's peel the onion two ways here, right? So one is just solving any problem that we talk about. I think Pallavi was mentioning that AI is becoming more like a tool that will be in the hands of different kinds of people to solve the problems that they are working on in their domain, right? So that's the direction in which generally applied AI is moving, right? It will get more and more democratized. To solve problems, a more important thing would be, hey, your understanding of the problem, the domain, the context than your understanding of just the core, the technical aspects of the AI. Yeah, of course, both are important. And when you solve these big problems, all these brains need to come together. But I'm just sticking my neck out that way by saying, hey, you know, how important understanding of these other areas is going to be, right? So, which means if you were to be, you know, if you were to think of yourself solving some of these problems in the future using AI, you know, whether you are, you might or might not be trained as an expert in AI, but so long as you are viewing, you understand what AI can do, what are its capabilities, you understand you know, things at a certain level, you should be able to know, and you understand the domain or the problem in which you're trying to solve, then that would be the right approach. I'll give you an example. One of the first problems I was working, you know, as as a graduate research student several years ago was, we're trying to simulate policy decisions, right? To say, hey, how can public policy, what would be the right way? Where should the right investment? What should be the right investments? You know, given a city. So the exercise we took up on was, hey, you know, let's simulate this whole city, and then we will simulate, hey, what's the implication of putting this, developing this neighborhood, or laying that road there, or building that employment center there, and then see impact on, you know, the broader society, right? So I jumped in saying that, hey, you know, I'm the tech guy. I know how to model using math, get it started. But pretty soon we realized that, hey, you know, this needed so much more holistic thinking, right? We had a group where there were economists, right? Where there were people from public policy, where there are people from sociology, right? Who would think about how would people behave in these things, and then how do you simulate that specific behavior in your simulations, right? So you see, any when you try to tackle any such problem, there's going to be you need the additional dimension of understanding what exactly are you solving, right? It's not just about the technology. So this is one dimension which ties to the other topic Kala was talking about, saying, hey, is it just going to be computers and math, or is there going to be something else? So yes, it's a big something else, and this is going to play a big part. And in terms of challenges, I'll reiterate this again. Aparna mentioned this right ahead, saying, hey, who is going to think about ethics in AI? Who is going to talk about, is whatever we have built, there is this AI that's functioning, is it fair? No, is the outcomes that are coming out of it, are they biased? Are they fair, right? Things start to extend beyond it being a pure tech problem, right? You're getting into realms today, we're not even sure how to tackle a lot of these. Why aren't self-driving cars today completely on the road? Technology is there, right? So, but there are other things like, hey, if an accident happens, who is responsible, right? How does the software make a decision when choosing between two bad outcomes? These are things we just don't have a grapple on yet, right? So there'll be more and more of these coming along our way as AI becomes more and more embedded in our lives, right? So I see big challenges ahead of us on these, I don't know, we call the philosophical, ethical aspects of AI and how that translate to policy, right? So that will need to do a lot of catching up while the technical things will keep progressing fast, right? That's a juggernaut that's already on, but there's a lot of catching up to do on that. For those of you interested in policy and such.
Yeah. No, very interesting. The whole ethics and philosophical perspectives of AI is very close to our heart at Krea, and I'm going to come around to Gaurav later after Aparna reflects on this. So Aparna, I mean, just your team itself and what's happening at Google and the whole team of AI for social good is working at something that's much larger. I mean, clearly, there is a whole philosophy on which your team is actually working on. So what are some of those larger complex problems that you're working on, and how does it typically work? I mean, you're obviously not just having technical people working on some of these solutions, isn't it? And you're looking at the whole application and the contextualization of some of the solutions, because if effectively you're talking about using AI for society's good.
Yeah, you're absolutely right. Like being part of this team has really opened my eyes to what AI can be applied to. Like it has become so interdisciplinary at this moment, starting from a very, in my previous problem that I was working on, which I mentioned, using satellite imagery and doing machine learning. For instance, there was a problem called estimating soil moisture, and apparently this is soil moisture is like moisture in the soil, like ground, how much groundwater there exists. And apparently, this is a very important problem. It can be used for, estimating how crops, what the yield would be, what would be the good crops to sow in an area, which really impacts farmers and their income, or how should the government distribute water depending on these factors. And it's just one of the things, right? You can use sensors, you can use satellite images, and so there is a lot of like hydrology at play. So we obviously do not have expertise in all of this. So we do rely on the expertise of hydrologists and remote sensing scientists to understand all of these parameters. And this is still somewhat scientific, technical, more in our domain. But coming to the AI for social good team, so I can briefly explain two of the projects that I'm involved with. So one is with an NGO called Arman. What they do is they're working towards the increasing awareness among women who are pregnant or have given birth recently. So it would send like automated voice messages every week or so and telling them, let's say you should take your iron supplements, or if you start facing headaches, you should maybe consult a doctor, it might be something serious, and so on. So generally, and of course this is amongst the lower income women we're targeting, so generally to generate awareness around their health. And as a ML person, I could just take all the data the NGO gives me and, like I said, throw it into a black box, but it doesn't work. There is so much at play here. The socioeconomic characteristics of these women. What's their income group? What's their education level? What's their age? How many times have they given birth before? Did they have complications? Often we hear that when the women come to the community center to enroll themselves in the program, they're accompanied by a family member, and sometimes they're hesitant to even reveal, if you are asked, have you had an abortion? A woman might be hesitant to say this. So there is so much, it was so fascinating to hear from the NGO, so what I would have never thought as a, technical person of what all can come into play into impacting this. So our goal here is to basically keep these women engaged in the program. And so we listen, we have records, we have their call records that whether they answered the call or not, whether they listened to it or not. And depending on this, we can infer whether these women are engaging or not. And our goal is to keep these women engaged as long as possible, of course, so that, they're aware of the importance of things. And for which we use machine learning. So we train a model to detect women we think are at high risk of dropping off from the program, looking at their past engagement behavior, which women we think might drop off. And in that case, we will call them personally, like some community health worker will call them personally and ask them, what's the reason that you do not engage? Is it because, the timing is not great for you? Is it because you don't understand the language we're calling you in? Is it because the phone doesn't belong to you? In many cases, the phone belongs to the husband and he comes back home at 9 o'clock in the night. So the woman doesn't have access to a phone. So there are so many interesting things at play here that, yeah, you're absolutely right that just knowing computer science and mathematics does not cut it at all. We have to understand so many factors. And there's another project, for instance, with WCT, that they're looking at human-wildlife conflict. So in rural areas where there is a forest, in the neighborhood of a village and some farms, and sometimes there might be a tiger or another dangerous animal that can enter a village or is lurking in the forest, and a human life is at risk. So we want to generate predictions here as to, depending on whatever input signals we have, whether there is a wild animal loose somewhere. So generate warnings in the village to not use the forest or not use this path these days. Again, this is like very, very sensitive. Literally, somebody's life is at play here. And you need to understand not just that I can just generate a prediction, like somebody said, you can't just draw a graph and say, oh yeah, this looks like, at this, above this threshold, there is a high risk. You can't do that, because if you start generating warnings every other day, people will stop listening to you. They won't take it seriously. They need to travel for work. They need to feed their families. They can get killed by a tiger, but they can also die of starvation. And on the other hand, when you genuinely generate a significant warning that yes, this is a high risk, how do you even send the message? How do you explain to people the importance of this, and how do you actually execute this warning? Do you put up fences? Do you give some incentives to people saying, if you don't go, we'll pay you somehow, or if any damage is done to your crops, we'll pay for it, but please do not risk your life. So you're absolutely right. Like I said, with this all these diverse projects we've been involved with, we've needed remote sensing people, we've needed hydrologists, we've needed maternity specialists, and yeah. So it's really fascinating how interdisciplinary it is at the moment.
Yeah. And we are hearing a lot more of psychology and the social scientists being extremely engaged. Gaurav, I wanted your thought on that. Before that, I just wanted to share, I mean, there was a bit of an audience poll here. We asked our students listening in, I think the power of AI can be best leveraged for what? And it's quite interesting that people did, 50% did think kind of improvement in life. And I guess to some extent, urban development is maybe improved life, but, and advancement in size. So that's, it's interesting to kind of hear that and see that there is not so much in terms of the consumer end of it. So thanks for sharing that poll, Chirantan. So Gaurav, just wanted your thoughts a bit about, there's a few things we've discussed here, and I really wanted your reflections around a couple of areas. One, of course, we talked about some of these larger complex problems, and really is mathematical and coding skills alone going to cut it? But also to touch a bit around this whole angle of ethics that Pradeep and Aparna hinted upon, and how important is that going to be in the whole realm of students who are studying computer science and mathematics and looking to create a career for themselves in the world of AI and data?
I'm critical. I mean, if you talk to anybody these days. So I think the two skills that people talk about sort of holistic understanding. I think two things really come out if I just take a step back. One is getting used to the idea of design thinking, right? Because any new area that you look at, any new problem you look at, you want to look at it from a very 360-degree point of view. That's one. Second thing is, I think one really needs to start developing the habit of learning how to learn. Whatever you learn right now, the next problem will not be good enough. You'll have to, again, within the context of Aparna said, you're talking to a hydrologist, you're talking to somebody else, you'll really have to develop the habit of learning how to learn as well. So it's not I've learned a certain skill set and that's going to be good enough for me for my tech career. It's just simply not going to be the case. And so while you can pick up a certain set of domain skills while, let's say, you within university, those domain skills will just never be enough. You'll always have to keep upgrading yourself. And on the specific point of sort of ethics and fairness, I think this is a great opportunity to look at political theorists like John Rawls in the last century and try and read elements of political theory and see which elements of that can be turned into algorithmic form. There's been almost a century of work that has gone on. And so this notion of algorithmic fairness, privacy-aware machine learning is just growing in importance. Because the issue with AI is that it can do things efficiently and at scale, which is great. But if you have elements of unfairness, that will also happen at scale. And so, it can sometimes act as a little bit of a double-edged sword, so to speak. So, especially when it comes to things like financial services, are you giving people loans or not? Healthcare. Right? Then, there's extra sensitivity on elements of fairness and ethics. And so I just want to sort of highlight that point sort of once again.
Yeah, and the whole interdisciplinarity, Gaurav, so if you can just comment a bit around how I mean, you're a professor of computer science and mathematics itself, but where do you see those interfaces happening with some of the other disciplines, and how critical is that going to be, the interface of mathematicians and computer scientists? And I want to really highlight that it's interesting how at Krea we don't really silo academics as they are. We're talking about it coming together. So your thoughts around, you know, because this whole discussion is about how some of this interdisciplinarity is going to work for the future.
Indeed, I think apart from math and let's say computer science, you know, as sort of knowing elements of mathematics and computer science, I think one really needs to also develop expertise in modeling. That is taking situations which might pose themselves in certain unstructured ways and casting them within a certain mathematical form. And so I think, well, now that can be done repeatedly with multiple disciplines or in different contexts if you're working in the real world and in the industrial context. And for that, I think some of the additional skills, you know, we've talked about specific academic skills, you know, academic disciplines like psychology or political science and whatnot. But I do think that some of the other skills that would be needed would be skills around our ability to think, our ability to create and solve, our ability to communicate, our ability to collaborate, and our ability to lead.
To what? The last one?
Leading.
Okay.
That is, you know, I think all of these additional skills will also be required apart from the domain skills and the interdisciplinary skills. How to put all of this together will require critical thinking, critical reasoning, being able to define questions, being able to structure and execute solutions, being able to speak right and communicate effectively. You get the wrong question, you will get the right answer to the wrong question. Right? So, you know, and collaborating, and, you know, because what you've heard is in terms of the interdisciplinarity, is you've got to talk to other people. You know, you've got to learn how to manage teams. You've got to learn how to listen. And those are, I think, are, you know, these 4 or 5 other points that I've mentioned are, I think, in my opinion, at least equally important. Apart from, so you can put it in 3 bins. One is the interdisciplinarity bin, one's the toolkit in terms of math and computer science, and one are these kind of skills in the workspace, or skills to create workable, executable solutions.
Yeah. Those 3 buckets of students, if you kind of gathered what Gaurav really said there was about, one is, you know, the whole T we are talking about is what you are doing in your domain of mathematics and computer science, but what you do across the other disciplines and beyond that. And that alone doesn't get you equipped enough to work in some of these complex problems, but there's a whole suite of other skills in terms of to lead, to collaborate, to think critically, and the whole modeling bit that he spoke about. I want to have this one last question to Pallavi and then come around for some very important student questions that come here. Pallavi, I wanted you to reflect a bit about, you know, with so many of these students here in school and the way we are teaching computer science and mathematics in school itself, and are we preparing, are the students itself being prepared enough in terms of their understanding of how you know, they're grouped, and how are they interacting with other disciplines within the school, and how are they understanding the impact of what they're studying in computer science and mathematics reflect on other areas of, let's say, your other class students who are studying psychology or social studies. So is that collaboration actually happening at school level for students to start early and think about this, not as silos, but more broadly?
Absolutely. I think no knowledge, any subject can be insular anymore. It cannot be siloed, because we have something called the interdisciplinary units, where we identify a concept and we approach that concept through several subjects. So we can have English, math, and say physics. And so the child learns to think from a different point of view. The perspective is enhanced. And one thing that's very clear to at least IB students is that you cannot, if you are a mathematician, you cannot not be creative, or you cannot not be not have communication skills. All of these are intertwined. These skills, like Gaurav was mentioning, you cannot do away with one or the other, because they all converge And in that sense, yes, most definitely computer science, the way it has been taught now recently in schools, has undergone a massive change, because we do, for example, some units of computer science we do through poetry. Would you believe that? So, where we ask them to look at things very, very differently. And the whole idea is to reflect on biases and assumptions, because that's one thing that very often when you have a very singular approach to anything, you become very close minded, whereas mathematics, I feel, is an international language. You can be of any nationality, you can be of any race, but sort of numbers everybody understands. So I feel, yes, there is definitely a big change in the way computer science is being taught in schools, and the way the students, our students now, or your students in Krea, should approach and understand, because you have to diversify. You cannot be singular in your approach.
Yeah.
Thank you.
Thanks. Thank you. Prathamesh, I wanted to kind of touch upon that. There's a lot of questions in terms of how Krea approaches it. And you basically lead our, to just for the benefit of our panelists, the non-Krea panelists and everybody attending here, Krea has a very structured first-year curriculum. And irrespective of whether you come to study literature or psychology or biology or whatever, you will do certain subjects in data. And there is a compulsory subject in mathematical reasoning, where it's about getting students comfortable with numbers. It's about getting them comfortable with technology and data, which we believe is a core skill before they go ahead and specialize in anything. So it doesn't matter. And that's probably also telling a lot about how we see the use of technology and data, very important. And clearly the three buckets of the future, the customer centricity, data centricity, technology centricity is going to rule much of our decision making, and how are we preparing some of these students for that. So Prathamesh, I wanted to ask a bit about your what you do at the first year at Krea, and especially around the data curriculum. How application oriented is it? And how do you bring some of the other disciplines in the way in which you actually teach some of these data concepts to students?
Thanks, Kala. So yeah, as we do have like multiple courses, as you said, which kind of hint towards your passion towards data, for instance, the math reasoning, the data analytics, as well as ICT. So I can briefly touch upon what we really do in the data analytics course. And so for instance, the course by itself begins with a whole series on how data itself is used in multiple disciplines. So for instance, we have a historian who can come and talk about how do you actually use data to discover where exactly you can find your next Ashoka edict, right? We can have an ecologist coming and talking about how do we really understand like the change of lantana growth across different parts of a forest, right? How do we really map the kind of spatial data that you have? And how do you really estimate? Because estimating number of forest production a tree is a hard choice by itself. Or let's say we have a biologist talking about epidemic spreading in, which is as topical as it gets and important as it gets today. So, and then we actually take people through a wide range of techniques where we kind of intersperse these examples as not just coming out of thin air and out of isolation, but as all these techniques are something that is kind of drawn upon from very concrete real life examples, and essentially help us model and understand really real life examples. And especially when we're talking about first years, we also have to remember these are not necessarily students who have come in with an aim of majoring in any quantitative discipline or a science, or even basically we're also not talking about students who necessarily have a background in anything very specific to science or anything quantitative. So we have to kind of, while we do it, we also do it in a fashion that is basically pitched at a level that's broad enough and can be basically accessed at students regardless of the kind of background they come from. And after that, we also kind of introduce two very different aspects of it. So which was something that was very unique we came up with was we have a whole series of things on basically use and misuse of data, where we give students case studies to understand, let's say, for instance, how do we really look at data and what kind of uses and misuses kind of can potentially be done and what exactly have existed in the literature. So we take newspaper reports. For instance, there's a paper, I don't know if people have come across, it was published in one of the British health journals, which talks about the correlation between the number of Nobel Prize winners and chocolate consumption, and tells you how actually the more you consume chocolates, the higher are your chances of being scientifically good as a nation. But then you basically forget a third variable, that richer countries actually consume more chocolate, and they also, perhaps richer countries can afford spending more on the scientific research leading to that, right? So, I mean, this kind of very spurious correlations that people often do. We kind of go through a whole list of them that you can actually find in the existing literature, and the kind of techniques and the kind of tests that you need to do when you kind of see such spurious thing, right? And for instance, it can be about, let's say, war casualties or anything to that effect. And then we also kind of get into various questions on, let's say, ethics and ethics of data. And for instance, within Krea itself, for instance, there's a very nice episode from Yes Minister, which I screened in my class, called The Big Brother. So where we kind of basically, which actually has some nice questions and nice points to make about how do we really understand data when it is actually being used in public domain, what kind of privacy concerns there is, what kind of protection mechanisms we can think about. So into a very funny episode, it actually documents some really interesting points there. So we actually had a nice discussion on how would you really design this if you had to, within the classroom itself, if you had certain data of yours that you would want to make available publicly, or if you don't want it to be available, what kind of data would you want it to be available to your other classmates about you? What kind of data you don't want it to be available, right? You want to keep it private. So when these kind of questions get people thinking, they kind of get thinking about ethics of data concern. What kind of protocol should be exist within sharing of data? So questions such as that is what we kind of really deal with and touch upon in Krea within the data curriculum.
Okay, so the approach is all that bit that Gaurav talked about. One is across the disciplines with different case studies that you're talking about, and the other is some of these pertinent questions about the use and the misuse of data. Thank you. I think that was really insightful. I haven't really heard too much about how we teach that in the first year, so I'm quite excited with what students will actually be going through. I know we've completed a bit about a lot of moderated questions otherwise, and I want to take some of the questions that came prior to the panel to us and want to run some of the questions that's come here. Of course, this is a question that will definitely come, and I was expecting this. So Pradeep, I'd like for you to kind of answer this. It comes from Stuti, and she says, with so much personal data on display, how much privacy will the future guarantee in the field of AI? Pradeep, is that something you want to go for?
Tough one. I think the more data, there will be an, I think generally we'll move towards a policy where you would have an option to safeguard parts of your whatever personal data that you would not want to share. I think generally I can see some trends in that direction. So you will have that opportunity. But what will also become very clear is the benefits of personalization and a lot of just the way today AI is being used today. The trade-offs between sharing them and benefiting from what the whole AI is able to do. A lot of people will say, it's a fair trade-off. All right, I'm willing to part with that confidentiality, that privacy, for the benefit of what I'll get. But my sense is, as we go along, I'm hoping all of us will have an option to say, hey, no, I'm okay with not getting the benefits of this, but with with me having control of my data. So I'm hoping there'll be such trade-offs and such choices that could be made.
Yeah, and I guess to a large extent also the common awareness of what's private data is also very low. I remember when Arogya Setu came, everyone like, don't put it, it's, they're taking your data, but like your date of birth and your Aadhaar is across so many other domains that you're entering, and you're very comfortable to make an online purchase or to put it on an Amazon and you don't think twice about it. But the moment it kind of comes in an app, and then slowly you kind of start to realize that, oh wow, it's easy to put in the app. It tracks when I got my vaccinations. It gives out my certificate. It makes sense. So it's sometimes about what is privacy, what is private data, and at what point should you be concerned? Aparna, is there too many red alarms out there talking about data privacy without people actually understanding what that is, you think?
Yeah, I think also continuing with what Pradeep said, like, of course, there are benefits to it, right? So I can give a personal example of how it was used. I used to work for the Google Maps team, specifically working towards improving search quality of maps on India, where we have so many diverse languages and mix up of languages. A user might write a query like, whereas, I don't know, mixing Hindi and English, and by, having some knowledge of the, I wouldn't say specific user profile, but by looking, by understanding, by looking at all these queries, by having that knowledge, we can obviously serve results better. We can understand this is not one, this is neither Hindi nor English, it's a mix. Also, for instance, when you search something, Google would ask you, is it okay to access your location? And people might freak out thinking, oh my God, Google is tracking me, it knows I'm doing this. And it's not like that, right? So I understand that it can be misinterpreted, and I guess it is somewhat also on the companies to give a better explanation, to explain it better how this data is going to be used. Like, yes, it is used, like Pradeep mentioned, to some extent to improve the experience for the user, but still there should be better awareness of how it will be used and how it will not be used, so as to alleviate some fears.
Yeah, thank you. There's an interesting question there about, I know Maitri's posted a question there. How relevant is AI ethicist as a career option in today's industry? And what exactly goes into making an AI ethicist? Gaurav, do you want to give it a go?
The answer can be really simple. Yes, and nobody knows.
Fair enough, yeah.
So, I mean, realistically speaking, so what would an AI ethicist do? Number one, you need to know AI, right? And I think reading across different disciplines and getting a sense of what constitutes fairness and what is ethically fair or not, and then having lots of case studies and experience and applying this in different contexts. And that, I think, would then constitute, an AI ethicist, so to speak. So yeah, I mean, I think it's very much a developing area, and I think it will turn out to be what you kind of make of it, so to speak, which is, just seeing it applied in very, very different contexts, and then developing that kind of sense of what is fairer than there. So I think it's nice to have the sort of European view that the world will be perfectly fair, but as long as you start with the view of let's keep making it fairer, I think that might be a reasonable compromise to sort of start with, so to speak.
Yeah, interesting. Samaya has a question, and I might ask Prathamesh if you want to give it a go at it, and then definitely have Aparna reflect on this. Is how will the advancements in AI, of course, impact environment, and in terms of, is sustainable development a possibility with the application of AI? So, Prathamesh, do you want to quote a bit around this whole the environment focus of AI that we run in class, and any examples from there?
Okay, yes, actually, so within class, yes, we do some of these things, but in general, I think a more interesting kind of a question would be, how does AI as a state-of-art research essentially affect, like, how do we really affect environment in that sense, right? So for instance, when we really just look at climate itself, right? I mean, making climate-based predictions, building climate-based models, I mean, these are very hard jobs. I mean, essentially, traditionally, people used a bunch of physicsy techniques using Navier-Stokes and on. But in recent times, with the kind of data that we kind of available to get, you actually use a fair number of very complex machine learning techniques to be able to understand, for instance, link between, let's say, increase in aerosol, which kind of decreases your temperature, to versus basically a global trend towards industrial pollutant gases. And when you actually have a bunch of factors which are actually counteracting and affecting each other, how do you really build predictions of basically how exactly climate systems evolve? And you often use a whole range of techniques from across and use the machine learning models today to be able to understand your climate sciences much, much better, or even the kind of fluid dynamics essentially affects. So that's one definitely very specific thing. And within especially much more a local scale, where we really look at, let's say, something like your environmental sustainability of, let's say, of an industrial unit, right? I mean, you have multiple factors that essentially have, which go into acting and counteracting, and you want to really know what exactly is your most sustainable process involving, for instance, for if you want to, let's say, construct a building, right? And what kind of decisions, and you often have to make these kind of trade-offs essentially that are often involved in terms of either if I go this way, these will be blah 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 factors that will occur, or if I choose this, this is going to be the set of outcomes that I'm going to happen. So often people now use very automated decision making tools to enable to understand and basically optimize on how do you actually make a sustainable process, right from basically starting right now planning your architecture of a building, to essentially finally how do we really have your zero waste energy or plumbing architecture within a construction unit. So quite a few data actually kind of gets into making a building a more sustainable future there.
Aparna, anything from your work in terms of examples? I know you quoted one or two, but is there anything more broader in terms of the environment as a total subject?
Absolutely. So like the goal of, like I mentioned, in that team was to use satellite imagery, which is publicly available. For instance, in our case, we were using imagery which is publicly available through Google Earth Engine, and to build models, train ML models on these images to generate predictions. Maybe, like I mentioned, one was soil moisture, estimating soil moisture in a region, or estimating whether this pixel looks like a forest, does it look like a river, does it look like snow, does it look like an urban development, and so on. And our hope was to release all this information publicly, to be, to have a global model that is available publicly to the entire research community and not just, within Google, so that, everyone can capitalize on this. And it could be a scientist working on climate modeling, it could be a scientist working on CO2 emissions, it could be someone, some civic society doing some planning for water distribution and so on. And like coming to sustainability, for instance, an interesting problem we saw was in the rural parts of India, somebody wanted to actually do a better distribution of water in collaboration with the government. For instance, to be able to predict, if you were to grow this crop versus this crop. Some crops like rice and wheat are very heavy on water consumption. They're very water demanding. So they should be grown in regions which have those resources or can have those resources. And not just, because there's the incentive of growing these crops. These are, very heavily consumed in India. So let's keep growing them, even if it comes at the cost of depleting all the water resources in that village. We might not see it that it's going to happen in the 5 years, 10 years, but we have large amounts of data to predict that, if we continue with this trend, what could happen? So we can provide alternative solutions to say, if instead of growing this crop or something else, what would the situation change like? So yeah, AI can have a large part in sustainability.
One question here, we have 10 minutes, but I want a couple of questions I want to run through quickly. Pallavi, this comes to you from Kushi. So are the teachers in your school at the threat of being replaced by machines?
Yeah, I'm struggling with my camera. 1 second.
No problem.
Yes. Oh no, absolutely not. Because we feel that, like I had said at the very beginning, teachers are not going to be threatened. They are going to be supported through AI. Because like I truly believe that AI, so we have Rose Luckin, who is a leading name in the AI industry, who is developing our education strategy. And we are working on using AI to develop smart lessons where we can, create customized lessons for different ability students. And so, no, I do not think it will wipe out any profession, especially not teaching, because teaching requires empathy, it requires creativity. And as of now, I don't think it can be replaced by a machine.
Kushi, you're going to be still taught by humans for a long time. And even after you come into Krea, there's not going to be much chance that you're going to see some of these professors. I want to kind of work around the last 5 minutes to talk with Pradeep and Aparna one more. And I guess that's because of this whole focus on the careers out here. So clearly, if we are talking analytics, you're going to talk about a company like Tiger Analytics, which is an ambitious company that every young student who, whether it's coming out of an IIT or out of a Krea, will actually be excited to join. So Pradeep, if you are looking at a young graduate who's come with the kind of mathematics and computer science background required to work in analytics, what are you looking for beyond that academic credentials from a young graduate to be able to be part of some of the work that you're doing at Tiger?
So I would answer this question slightly differently, right? In terms of, maybe I'll answer it in terms of, hey, what will it really take for people to really thrive in their careers? No, not just get into a team. And if students listening in haven't made notes of what Gaurav was saying in terms of those specific skill sets beyond the technical and domain things, right? The critical thinking, taking initiative, leading, collaboration, ability to communicate your thoughts, persuasion. These seem very, very soft skills, but these are the ones that just bring people together to solve these problems, right? So these are very complex problems you're solving, and you will not have answers to everyone, right? And you will have people who are coming in with different worldviews, different perspectives, and all of them are working in a team. And unless everyone gets together, these are problems that cannot be solved. And each one is an expert in their own right, in their own field. If you're coming in from a very technical computer science, math background, maybe over a period of time you would be you would be responsible for that aspect. But equally, you have someone maybe from an economics from somewhere, maybe from business, someone else who's equally strong in those areas. And how do you work together, right? How do you rally the group together, right? There are a lot of these aspects, the human aspects that come up, which I think broadly, tongue-in-cheek, AI is far from solving those. But those will be things that will take you far in your careers. Those are things very hard to evaluate in any interview. Usually most interviews tend to be a bit more technical in nature. They're just evaluating you for you are a math and a computer science graduate, on those specific skills. But beyond that, your growth, the kind of impact you are able to have in an organization or any problem that you're solving will hinge a lot on these things, right? Definitely make notes of those things that Professor Gaurav was saying. Design thinking is just imbibing this approach of looking at problems is just giving everyone a new perspective on saying, oh my God, I completely haven't been thinking about this. I was just thinking about my area, but hey, this I can approach this in a very different manner, right? So the non-technical aspects around these things, whether it is leadership, collaboration, persuasion, design thinking, these are ones that will be game changers for you, in your careers.
Excellent, excellently put. And Aparna, I mean, if I was a computer scientist applying to Google, how would you differentiate between a computer scientist and a better computer scientist?
Okay, one thing goes without saying is, it might sound obvious, but it is true, is passion. You do something with passion, the rewards, the results will follow. And I know it's an easy thing to say, but it really holds true in life. I mean, sure, you could go for, the obvious, the big jobs, or, the title or whatever. But, when you do something passionately, everything else just falls in place. And secondly, what I would, what we would appreciate is, so I'll take an analogy from machine learning, specifically from reinforcement learning, called exploitation and exploration. When you throw a robot into a new environment, it knows nothing about it. So it starts exploring, what can I do? And should I take this door? Should I go down? Should I go down the stairs? Or is this a wall I cannot pass through? And so on. And versus exploiting. When it knows something, then it can make a confident decision that, oh, I know if this is a wall, there's no way I can pass through it. Or this might look like a door to go somewhere, but if it's going down a staircase, it's dangerous. So there is this, always this balance of exploring versus exploiting, exploring something new, taking risks, versus doing something which seems safe, well-known, familiar. So don't be afraid to explore. You're too young, you're in an amazing university where you can explore different domains, do all sorts of courses, to talk to your friends in other departments, just, broaden your horizons. Also get a richer experience. You have these opportunities, maybe to explore doing internships in different kinds of companies, different types of environments, maybe in an academic institute, in an industrial place, attend summer schools, attend a conference if you can, think beyond the obvious, I mean, of course, your courses are important, your projects are important, but see beyond the obvious that you see, your projects, your assignments, and so on. Really broaden your horizons, and hopefully, then what your passion is, what your calling is, and then and all the collective experience is going to help you.
Yeah. Thank you so much. I mean, that echoed so much for, I mean, something we do. And at Krea, at the end of the first year, we get all the students to work on a social impact project. We kind of get them to apply, so the first year, really, they do design thinking, they do ethics, creative expressions, data, all of that, which is really embedded. And one of the things we insist is you're not ready for the for-profit. You should first sensitize yourself to see where all of this applies for impact at the end of the first year, and then they progress after the second year. When they've picked the majors is when they actually start to go and work in industry, and either it's a major, minor with a concentration, or however they want to kind of work around it. So it's quite heartening to see some of that being announced, and credit to people like Gaurav who sit on that academic council and putting together the kind of approach that we have at Krea. And thank you so much for all of that. Gaurav, is there anything you want to specifically talk about the first year, the design thinking, the ethics and thing, and we can close with that? Anything specific you want to leave our students with?
Without going into any details, to sort of as a summary, I think one of the ways that the first year Krea has been designed is to try and enhance creativity, curiosity, and a learning mindset without going into any of the specifics. Right? Whether it's what the various courses are. And I think as life goes on, and as it's very natural to think, what am I going to do in life? What career do I want? And so on and so forth. I mean, everybody goes through it. And honestly, I'm still going through it right now myself. I mean, I retrained myself in artificial intelligence and machine learning 5 years ago, 4 or 5 years ago. And 10 years from now, I'll probably be doing something completely different. So I think in this sort of new world, as long as there is creativity, as long as there's curiosity and a learning and a growth mindset, everything's a learning experience. And I think it's a wonderful time to be alive now. I really do think so, because of all the innovations and all these sort of fantastic things that technology will bring to mind, which allows us to be more human, so to speak, and not spend our time doing more mechanical optimizing tasks.
Yeah. And Nishka, hopefully that answered your final question, and where AI can never be part of. I don't know whether AI can never be part of, but no professions can be wholly, solved by AI. We've seen that whole human element of it come across, and all the other skills that our panelists here spoke about. So you heard them. These are some of the top practitioners from the field of education in computer science and mathematics, and industry practitioners. You heard from them in terms of how, not just where AI and data has arrived, where it's going, and importantly, what's going to probably get through the next frontiers is not just that siloed academic depth in coding and computer science and mathematics, but it's across how you can contextualize and go across other disciplines, and also develop some of those core skills that Dr. Gaurav Rana is actually mentioning there. We're extremely delighted to conclude this, and it's been a fantastic 90 minutes talking through. Time actually just breezed by. Thank you so much, Pradeep, Aparna, Prathamesh, Pallavi, and Gaurav, for your time. It's been wonderful hearing the different perspectives, and with every panel, I often hear the panel says, I learned from each other, and that's always interesting notes to take back home. We hope you enjoyed this as much as we loved having you on board, and thank you so much for doing this. It's a very important initiative. We want to kind of keep having these dialogues across as micro levels as possible with students and parents and counselors. So thank you once again for your Saturday post-afternoon with us.